So today we're going to begin by teaching in our Calc 3 course, and we will begin with
5.1 double integrals over rectangular regions.
and then we will move on to 5.4 triple integrals.
For the first equation I'm going to be solving for 5.1, I'm going to do this integral right here. And these are double integrals, which means that you have one integral on the inside and then you have one on the outside. So when you read it left to right, it might look weird, but the easy way to look at it is to look from the inside to outside. So to do this, we're going to have our function and then we're going to have an integral. So that integral will correlate with the nearest d part on the outside. So these brackets, you don't need them, but it's easier to look at it. So for this first part, it's dy, and the outside is dx. Doesn't always have to be that way, but you just have to look and see which way will work best with your problem. So for the problem I'm going to be solving right now, I'm going to be solving this one. Negative 1 to 1, and then negative 2 to 2 of 2x plus 3y plus 5. So the first part that you do is you just solve this middle part as normal, as a normal integral. And because I'm going dx, not every part has a dx, and any part of the function that does not have a x, you just treat it as a constant, so it will be added an x. So to solve this integral, you carry on the outside integral, which is negative 1 to 1, and then you do solve the middle. So for this one, it's going to be x squared plus 3yx, because it's just a constant, so it just gets an x, plus 5x. And this will all be from negative 2 to 2. So now the answer from in here will just be carried on to this outside integral. So I'm going to solve it up here so it's easier to look at. So we got to plug in our bounds, negative 2 to 2. It's going to be 2 squared plus 3y times 2 plus 5 times 2. All minus negative 2 Alright, so this is going to be our function, our problem right here. So it's going to be 4 plus 6y plus 10, all minus 4 minus 6y minus 10. So now 4 minus 4 is 0. 6 minus minus, so just plus 6y equals 12y. And then minus minus, so plus 10 equals plus 20. So our answer is 12y plus 20. I'm just going to erase this to get some more room. So now I'm going to just plug this in to a function up here. So negative 1 to 1 of 12y plus 20 dy. So now the same thing that we did with the x's. Any part that does not have a y, we'll just add a y because it's a constant. So now it's going to be 12 over 2y squared plus 20y, all from negative 1 to 1. So now these cancel, 6y squared plus 20y. So now we can just plug in our bounds, negative 1 to 1. So this is going to end up being 6 plus 20, all of this minus the second part, negative 1 squared plus 20 times negative 1. So now we get 6 plus 20, all minus 6 minus 20. So now 6 plus 6, 12, and then plus 40. Actually no, the 6's cancel out, 6 minus 6, and then 20 plus 20. So the answer is 40. That's how you do 5.1.
Alright, so this section now will be 5.4, which is triple integrals. And essentially it's the same concept as double and regular integrals, however, now we're adding in the z portion. And if you think about it on a graph, you have the x and y coordinates, and typically you would take the integral to find an area within here. However, with triple integrals, now we're finding a volume. So that's where the z coordinate comes in. And instead of thinking on a 2D axis, you now will also have a 3D axis where this whole section pokes out of the board, okay? So, factoring that in, let's get to work. So, when we look at it, this is our z bounds, our y bounds, and our x bounds. And we know this because the order that we're asked to integrate in is dx, dy, dz. So we would just work backwards on the integrals. This first integral, the bounds are the x bounds. Second, the y are the y bounds. Lastly, z is the last bounds, okay? So here we go. Now when we integrate, we're integrating with respect to x right now. So we'll rewrite our first two bounds of 0 to 1 and 4 to 2, okay? And now when we integrate, this x will now become an x squared over 2 plus, and because this y z squared does not have an x, it is simply seen as a constant. So we just add an x to it. X, y, z squared with the bounds -1 to 5 dy dz, okay? And before we can continue moving on, just like in double integrals, we will have to solve out this integration, okay? So we plug in the 5, so we'll get 5 squared over 2 plus 5y z squared minus -1 squared over 2 plus -1 y z squared, okay? This is the equation that we will be given based on the bounds. And so we get 25 over 2 plus 5z yz squared. And this is essentially, if you were to square a -1, you get 1. So we're going to subtract, add in that negative, minus 1/2. And this is essentially going to be a minus yz squared times another negative. So we're going to get a plus yz squared, okay? And now when we come down and add all this together, we are given, we will combine like terms. 25 minus 1/2, 24 over 2, aka 12. And now we will combine 5 plus 5yz squared plus yz squared. So we will get a plus 6yz squared. So now that we have solved the first integral, now we have the integral of 0 to 1 and then 4 to 2 of the equation 12 plus 6yz squared, dy dz. And since dy is next in sequence, we're going to solve for the y variable, okay? So if we were to integrate this, we remain with our z integral, and now we solve. 12 is just a constant, so it gains a y. So 12y plus, and now if we were to integrate y here, you would get y squared over 2. So I'll write this up here just so we can visualize it. Y squared over 2. And this 2 can reduce this 6, so we will end up with 3y squared z squared from 2 to 4 dz, okay? So this is what we're left with. Now we have to solve this out, and anywhere we see a y, we plug in 4 and 2, okay? So we get 12 times 4 plus 3 times 4 squared z squared minus 12 times 2 plus 3 times 2 squared z squared. Okay, so this is when we plug in our bounds, this is what we're left with to solve. So let's start multiplying it. 48 plus 3 times 4 squared is 16, z squared, minus 2 times 12, 24, plus 3 times 2 squared is 4, z squared. Okay? So we have 48 plus 3 times 16, which we can do right now. 16 times 3 is 8. We essentially have, we'll erase this right here. 48 z squared minus 24 times 3 times 4, which is 12 z squared. So now let's factor in this negative and let's get to subtracting. So now we have 48 plus 48 z squared minus 24 minus 12 z squared equals. So now we'll combine like terms. 48 minus 24 is 24. 48 z squared minus 12 z squared is plus 36 z squared. So now that we have integrated our x and our y, all we are left with is our z variable, okay? So now, simple enough, it's a single integral. So let's integrate. 24 will gain a z, because it's just a constant, plus z squared would now become z cubed over 3, and this 3 can reduce that 36 into a 12. So it becomes 12 z cubed with the bounds of 0 to 1. Simple enough, we have a 0 and 1. Let's add our bounds in. So we get 24 times 1 plus 12 times 1 cubed minus 24 times 0 plus 12 times 0 cubed. And this all zeroes out, so let's just cross that out, not worry about it. 24 times 1, 24. 12 times 1 cubed is plus 12. And so our answer is 36. So the integral with these set bounds of x plus y z squared is equal to 30. So let's get a quick little recap of what we've done in Calc 3. So in 5.1, which is double integrals over a rectangular region, because it is rectangular, it means all of our bounds are constants. There are no functions within our bounds. And 2D or double integrals can be used to calculate area of 2D regions, and these can be used to calculate things such as mass, density, electric charge, and inertia.
And to recap 5.4, which is triple integrals. Triple integrals can be used to calculate volume, mass, in 3D fields, and these can be used beyond rectangular regions, and these can be basically any shape. And triple integrals can also be used to calculate charge flux and distribution in real-world applications with electrical engineers. For the differential equations portion of this project, we're going to be solving 2.1 linear differential equations.
And then we'll move on to 2.2, which is separable equations.
Alright, to start off 2.1, we're going to look at this problem right here. So this is a problem that we would get in differential equations. And the first step, there's 5 main steps in this portion of the chapter. So the first thing we need to do is get all of this to basically look like this. So everything we do in this chapter will basically need your function to look somewhat like that. So right here, this is basically just v prime. It's just written out different. And also, these are based on y's, but most of the time these will be based on v's. It doesn't really matter. So first part, v prime equals 9.8 minus 0.196 v. So now this still does not look like this. We need this portion over here. So we're going to go v prime plus 0.196 v equals 9.8. So once we get to this step, now we have to find our m of t. So this is like a weird looking m. And to get this, to find this, the formula is e to the integral of what is before your v, which is in this case is 0.196. 0.196 dt. It's going to be dt right here. So to solve this integral, it's just going to be e to the 0.196 t. Because it's just a constant, it just gets a t. So now once we have this, we're going to throw it in and multiply it everywhere in our equation right here. This is going to be our original equation now on. Move over here. So now we're going to have 0.196 t v prime and then forgot the e, so we have that. Move the v prime down, and then we're going to multiply by this one right here. So for this one, it's going to be plus 0.196, throw it in right here, and then equals 9.8 e to the 0.196 t. Alright, this is right here, this is our third step. So now we're moving on to our fourth step. And one way to make sure that everything's going smoothly is that this function right here, the derivative should be right here. So the derivative of this is just what's up here minus the t. So right here, and then drops down in the front with the e. So right here we can see that we have that. So because we have that, now we can drop this part off for this portion of the step. So now we need to take the integral of both sides of this equation. So now it's going to be e to the 0.196 t v prime equals the 9.8 e to the 0.196 t. So now we just take the integral of both sides on this part. So now this v prime goes away basically because it's just taking the integral of that. And over here, we're going to get e to the 0.196 v, and then you're gonna have a plus c, but you're gonna have two plus c's, so you can combine them at the end. But for this part, I'm gonna just make this one k so that we don't get confused. And that's gonna equal 9.8 e to the 0.196 t all over 0.196 plus c. All right. Shit. Where's the wrong one? No, I didn't. And then to carry on from here, we can divide this out, and then we'll end up getting e to the 0.196 TV equals 50. This is right here. 9.8 divided by 0.196 is 50. E to the 0.196 t plus big C. So now on the final part, we're gonna move. We got to get v by itself. So we're gonna move e down up below. Now I'm gonna erase some stuff. Alright, now we're just going to divide this over. So now our v is going to equal 50e Alright, and this is our general solution. So now, if we wanted to, we could take it one step further and plug in bounds to find our c, which we're going to do. So the bounds we're going to put is v of 0 is going to equal 48. So now we plug this into anywhere we have stuff down here. So now v of 0 is basically our x, which is going to go right here. It's going to be 48 equals one more thing from right here is that we can separate this denominator into both sides, and right here it's going to cancel, but then our c is still going to have the e.196t. And an easier way to write this to make it better, so we're going to have 50 plus our c, and instead of having it on the denominator, we can put a negative in the exponent to make it from the bottom. 6, and then right here it's going to be 0. So then all we have to do is this turns into 0, which just makes this 1. So then we're just going to have to move our 50 over to the 48. This is going to be -2 equals c. So our big C is going to equal -2. Just rewrite everything for the final down here. Now our final equation is going to be v equals 50 plus -2, which is just going to be our c, and then e.196t. And this is our final equation right here.
So now we're going to move on to 2.2, which is separable equations. Okay? And when solving separable equations, you're often given an equation look like this, where you have y prime and a function of y and a function of x. Okay? However, before we can solve, our equation must look in this form, where it is our function of y, which is right here, y prime, put 2 lines under so you can see it, and then our function of x, which is also right there. However, if we look into our equation, we will see that this is not the format we're in. Our y prime and our function of y are not on the same side. So our first step of this equation will be to get our y function over to the side with the y prime. Okay? So I find it easier to keep this 6 on the right side with the x, which is no problem. The 6 is simply a constant. Either side works for this example. So simply all I will move over for step 1 is y to the second, and if we divide it out, we will get 1 over y squared, which is the same as y to the negative second. So we will have y to the negative second dy dx equals 6x. Okay? And now we have this in the proper form. We have our y function, our dy dx, aka y prime, and we have our x function, which is 6x. Okay? Step 2, we are going to integrate both sides. However, we cannot integrate with the dy dx. So we need dx to get onto the right side so we can integrate our x function, and we need dy alone so we can integrate our y function. So let's multiply dx across. We will get y to the negative second dy equals 6x dx. So now they're in the proper format so that we can integrate. Let's do so. We'll integrate. Okay. Our left side will become negative 1 over y plus c equals 3x squared plus c. Okay? Now, next, we will have to get these c's on the same side. If we subtract the c from both sides, since c is simply a constant that we are unaware of, that we don't know what it equals, our function just becomes negative 1 over y equals 3x squared plus c. And that is where we are finished with step 2. Step 3 of a 5-step process. 3 is to plug in our initial condition, which is y of 1 equals 1/25th. And when we look at this, our 1 is our x variable, our 1/25th is our y variable. Knowing that, we'll plug it into here, where -1 over 1/25th equals 3 times 1 squared plus c. Okay, let's solve it out. A fraction into a fraction, we'll flip the 25, it becomes -25 equals 3 times 1 squared is 3 plus c. And our last step now to solve for c is to subtract 3. So now c equals -28. Alright? And step 4. Step 4, we were going to plug our c back into our equation, and then we will check for interval of validity. Okay, so let's start by plugging c back in. 4. Our equation was -1 over y equals 3x squared. And instead of putting c, we will plug in -28. -28. Okay? And now how do we check for the interval of validity? So the way we do that is solve for x when x equals 0. However, we cannot do that right now because our y is 1 negative, 2 at the bottom of the fraction. So let's flip it and multiply by -1. So multiply by -1 and flip the equation. If we do so, y will equal 1 over, multiply all this by a negative, we will get a positive 28 minus 3x squared. Okay? And now we're left to solve that. If we can solve that, set it to equal 0, and we'll get our interval of validity. So 28 minus 3x squared equals 0. We will get 3x squared equals 28. Okay, we're gonna move this up here because I don't have any room. We will divide by 3 from both sides, so x squared equals 28 over 3. And last step is to put a radical on both sides so we can get that squared out of the way. So x equals plus or minus the square root of 28 over 3. And we have just enough room over here for step 5. Step 5 would be to plot this on some sort of graph. I'm just going to put a line graph right here just to make it simple, or a number line. So on the far left we have negative root 28 over 3, root 28 over 3, 0. And our interval of validity falls within some number c within the interval of negative root 28 over 3 to root 28 over 3. And that is how we solve separable equations. So we can recap our differential equation sections. 2.1, we will begin by setting our equation into this format, which is y prime plus p of y times y is equal to g of t. And from this, we will find our integrating factor, mu of t is equal to e to the integral of p of t dt. Next, we'll use our product rule to set our equation of mu of t times y of t prime is equal to g of t times mu of t. Okay? Once we have this, we'll integrate both sides of this equation, and from there we'll be able to solve for y of t.
And to recap 2.2, we start by separating our variables, and then we will get to where it looks like h of y times y prime equals g of x. Next step is to integrate both sides. Once you do that and get your solution, you gotta solve your initial values by plugging in the ones they give you to find your plus c. And then after all that, then you just use those values and everything to check your interval of validity.